How does the substance's strong scattering ability for electrons, about 10,000 times that of X-rays, benefit the study of material properties? Could this high scattering ability improve the resolution and precision of the diffraction patterns? How does the short exposure time in electron diffraction make it an efficient tool for studying materials? And how does this feature compare to the longer exposure times typically required for X-ray diffraction methods? How does TM, when combined with energy spectroscopy, allow for the characterization of the distribution of elements in nanomaterials? And why is this combination especially useful for studying heterogeneous structures? Could the combination of these techniques reveal detailed chemical composition information about different regions of the material, especially in complex or special heterogeneous structures? How does energy spectroscopy complement electron diffraction in TM by providing additional information on elemental composition? And how does it enable the detailed study of materials at the nanoscale, particularly in cases where variations in elemental distribution are important for understanding the material's properties? What is the nuclear magnetic resonance (NMR) technique, and how does it work? How does a spin nucleus in an external magnetic field H0 interact with electromagnetic radiation of a specific frequency (nu)? What happens when the energy of the radiation matches the energy difference between two orientations of the spin nucleus? How does the spin nucleus absorb the electromagnetic radiation and transition from a low energy state to a high energy state? What is this phenomenon called, and why is it important in the context of molecular analysis? What was the significance of Arnold's discovery in 1951 regarding the NMR signal of ethanol? And how did it relate to molecular structure? How did barium contribute to the development of NMR in 1953? And what was the first NMR instrument used to study? How did this instrument help to explore the effect of molecular structure on the magnetic field around hydrogen atoms? In what way did Varian's work in 1953 contribute to the development of NMR spectra for resolving molecular structures? How has NMR technology evolved over time, from the initial use of 1H spectroscopy to the more advanced techniques like 13C spectroscopy and two-dimensional NMR spectroscopy? What role has the evolution of NMR techniques played in enhancing our ability to resolve molecular structures? How did advancements in NMR technology after the 1990s lead to the exploration of tertiary structures of proteins? How did these advancements make it possible to determine the molecular structure of proteins in solution phase? What makes 1H NMR and 13C NMR the most widely studied and applied NMR spectra? How does 1H NMR or PMR help determine the position of hydrogen atoms in the carbon skeleton of molecules?